I'm Dartey. Welcome to the channel. On this channel, we help you solve your mathematics questions. A pyramid with vertex O stands on a square base ABCD, and line OA is equal to line OC equals to line OD equal to line AB, and is equal to 5 centimeters. Calculate A, the height of the pyramid; B, the volume of the pyramid; C, the angle between plane OAB and the base; D, the total surface area of the triangular faces; E, the angle between faces OAB and OCD. Right, so I need to draw the shape that they are talking about. The shape looks like this. Good. With my vectors O at the top, the sides are A, B, C, and D down there. And this is 5 centimeters. This is also 5 centimeters. Of course, the square, so this will be 5 centimeters as well. Good. Now, from the vertex to the middle of the square is the actual height of the pyramid. So I can also draw a different line. I can also draw lines touching the edges of the square down. Now, so from here I'm going to do some demonstrations. Now, if I take face, so this is the actual height. So this, if I take this side of the pyramid, I can have something like this, right? So this is my A. The midpoint here, let me make that to be V, and then the top is O. So I have a right angle triangle out of that. Of course, the side here is 5 centimeters, and the height I don't know. The line AV down here too, I don't know, but line AV is half of AD. Line AB is half of this line. So what I'll do is that, having written this down or having drawn this, I can also draw a shape which includes the down of a square. That's also a shape, and which of course is in the form of a right angle triangle. I'll have something also this way. So I have A, B, and C from the main diagram. AB is 5 centimeters. BC is also 5 centimeters. So I can find my AC. So applying the principle of Pythagoras theorem, line AC squared equal to line BC, which is 5 centimeters squared. Line AC 5 centimeters and line BC also 5 centimeters squared. So the answer for that all is 50. So to find line AC, I need to make a square root sign of that. So that should give me 7.07 centimeters. 7.07 centimeters. So that is the distance for AC. But don't forget, line AV is half of line AC. So I will have the answer I got for AC, that's 7.07, and that should give us 3.54 centimeters. 3.54 centimeters. So after getting your 3.54 centimeters, we can now go ahead and find the height of the pyramid. This is AV. This is the height. This was my X, so it's now 3.54, and this place is 5 centimeters. So I can now find the height. So again, applying Pythagoras theorem, 5 squared equal to 3.54 squared plus h squared. So 25 equal to 12.5 plus h squared. So when I do that, h squared will be 12.5. So h is equal to root of 12.5. H is equal to 3.54. So the height of the pyramid is 3.54 centimeters. So the volume of the pyramid. So after getting my height, I cannot go and find the volume. So 1/3 base area times my height. So my V is equal to 1/3. The base area, which is a square, and all the sides are the same for a square, and the side is 5. So 5 times 5, that gives me 25. The height is 3.54. When you do that, 9.5 cm cube. Next is to find the angle this face right here, that face AOB, makes with the base. So this angle makes this face makes an angle with the base at the down here. So we want to find that touching the middle of AB on a slant face, moving that line to the middle and joining it, so to have something like this. This is my vectors. This is from the V center, and this is in the middle of AB. So let me make that W. Now that is like B to the middle, or half of BC. B to the middle here, that is this line. So what I'll do is to have this. So this, the whole of this is 5 centimeters. Half of that is 2.5. So it means WV is 2.5. And my height is what I got to be 3.54. So with that, I can find the angle here. That's what we are looking for, the angle here. So using the trigonometric ratios, tan of the angle to be equal to opposite over adjacent, 2.5. So the angle will be tan inverse of 3.454 over 2.5. Your theta should be 54.77 in degrees. 54.77 in degrees. So that's the angle the face makes with the base OAB, face OAB and the base. That's the angle between them. So the next is to find the total surface area for all the triangular faces. So there are four triangular faces. This is 1, this is 2, the back and the back of this. So there are 4 triangular faces, but of course once they have a square base, the shape will be the same for all of them. So what I would need to do is to find the surface area for 1 and multiply that by 4. So this the shape for one of the surfaces or the faces. So to find the area, we need the base, which is times the height. So half the base times the height. We know the base already to be 5 centimeters. We need this. We know this side is also 5 centimeters. So drawing this, we need to find this vertical height. When you do that, it means you are dividing the 5 here into 2. So this place should be 2.5. Okay, so this is my one of my faces with 2.5, and I'm looking for this height. So what will happen is that I'll apply the principle of Pythagoras theorem to calculate for the height. So my height squared is equal to 5 squared minus 2.5 squared. So when you do that, your height will be 4.33 centimeters. So that's the height, but we needed area, so it means I'll have 1/2 times the base is 5, the base of the triangle is 5, and the height is 4.33. My area is 10.825 centimeters squared. So that's the area of one of the faces. You multiply 4 by your answer, 43.3 centimeters squared. So that becomes the total surface area of the triangular faces, all the 4. The next is to find the angle between faces OAB and OCD. So let me redraw my diagram. Now there's a height that's to the middle. Now so faces AOB, this face against the one at the back, so it means that the angle is at the top here. The angle is at the top, but I cannot find that angle at once. So what I need to do is that I'll take a right angle triangle from the diagram. This is from here to the top and coming back on this line. So that's what I've taken out. The height of the pyramid itself is 3 point. We got that to be 3.4, and the base here will be 2.5 because this is half of AD. So with that, I can find this angle here. That should give me tan. So I'm going to use tan of the angle there to be opposite over adjacent, 2.5 over 3.54. So my angle will be the tan inverse of 2.5 over 3.54. So my angle should be 35.23 degrees, but that is just for taking half of the angle at the top. So what I'll need to do here is to multiply this answer by 2 in order to get all the angles that the two faces make when they are in contact. That will give me 2 times 35.23 70.46 degrees. So that's the angle the two sides make when they are in contact.